All right. Hello, everyone. I'm Bernd, and today is day 4 of Advent of Code. Today's puzzle is all about sets. So if you have a look at the input, each line gives us two sets. So that will be, for example, the set containing the numbers 2 to 4 and the set containing the numbers 6 to 8. And then for the first part of the puzzle, we have to figure out if one set completely contains the other set. And for how many lines this is the case. So for example, if you have the set 2 to 8, then that does fully contain the set 3 to 7 and so on. That's already it for the first part. So how can we do that? So of course, first we need to read the input. And then we define for convenience a class sectioner. So when we initialize it, it gets a start and an end as an integer. And then we have the method contains, and it takes as an input the argument another section. And so that returns if the section contains the other section. So that mathematically means that the start of the first section needs to be as big as the start of the second section, and the end of the first section must be greater or equal the end of the other section. So yeah, having that defined, we can create a section from the section string. So the section string would be like, for example, 2 to 4 with a dash in the middle. So we take the string, split it by the dash, and then for each of the parts, we call the int to convert it to an integer. Then we can parse the whole line by just splitting the line by a comma and then calling section from string on both parts. And then we can solve the whole first part by setting the number of containments to 0, and then for each line, parsing the line into two sections, and then checking if the first section contains the second section, or the other way around, the second section contains the first section. If that's the case, we count that as a containment, and then we can print the number of containments. So we can write a little test, so we get a test input, and we know that the result is supposed to be 2. And if we run it, it actually does give us the right result, so that's great. We can run it on the actual input. For part 2 is similar, but we don't want to know if one set completely contains the other, but actually if the two sets overlap. So we again can extend our section class, and we can have this method overlaps that again takes another section as the argument. And we could just return this term, but I think it's easy to do it in multiple lines, or more easy to just understand. So the first section is completely before the other section if the end of the first section is smaller than the start of the other section. We know that the first section is completely after the other section if the start of the first section is after the end of the second sections. So then the two sections happen to be disjoint if the first section is either completely before or completely after the other section. And the two sections overlap if they're not disjoint, so we can return that. And that's a bit more lines, but I think conceptually a bit maybe easier. And again, the rest of the code is very similar to part 1. We have a function to convert this section string into sectioner. We want to parse lines. And then again, for this to solve the problem, we're going to want to go for the lines, parse the line into two sections, and then we check if the section 1 overlaps with section 2. We don't need to check have two terms there, because that already means that the section 2 also overlaps with section 1. And we count how often that happens and print that. And again, if we run it on our test inputs, the result is supposed to be 4. And that turns out that it's correct. So we can run it on the full puzzle input and get a solution. All right, that's it already for part 4. Hope you've enjoyed today's puzzle, and best of luck for future days, and see you around.